How's it going, everyone? Vlad here and welcome back to the channel. As you can see by the title on the whiteboard, today we're going to be talking about Git and version control as it pertains to manufacturing and industrial automation. We're going to start with the very basics. I'm going to give you a couple of explanations as to what Git really is, and ultimately we're going to get into some of the nuances on the OT side or operational technology side so that you could make better decisions and understand why there's certain challenges, but also why there are certain opportunities in the manufacturing and the industrial automation space. So this is relevant whether you're making decisions on the plant floor, if you're an engineer, if you're working with PLCs, HMIs, and SCADA systems, or if you're a decision maker, if you're a manager, perhaps a director or vice president, and if you're looking to solve some of the challenges you've seen on the production floor when it comes to some of software deployments. So let's start with the very basic question as to what is Git. So Git has been a very standard approach to version control on the software side for many years, and has been used in IT for over, I would say, a couple of decades. And the reason why it is used, so I'll give a very brief explanation of Git, there's tons of videos that explain this, is that you ultimately need multiple parties to build a software that is relevant in this day and age. So usually what happens is you start with the V1 of the software, right? So I'm going to label this as V1. Again, there's going to be different nomenclatures as you actually use Git. And so this is going to be your version 1 of the software. And let's assume that at this point, it is being built by a single individual. So if I'm a single individual, if I'm building the software, it doesn't necessarily matter that I keep building that on top of my own laptop, right? And as I deploy the software, it simply goes to version 2, for example, or let's say version 1.1, and then it goes to version 1.2. And so this software gets built very linearly. I'm the only developer. I'm just going to release the next version that is needed. Of course, this is all managed by a project manager, so there's going to be a little bit more nuance to all of this. Now, the challenges start happening as you introduce other parties in this development lifecycle. And so why do you need other parties? Ultimately, the most basic answer is that you're starting to have so much software, I want to say tasks to create, that it requires more than a single individual. So what happens in Git is that you can now split off this version to create a version that is going to be different from this V1. So this is, let's say, this V1.1, right? Because it branched off here, .1. Right? And so the problem here is that now you have person 1, so let's assume this is like person 2, and this is person 1 that's still working on the software. In a complex environment, you're going to have multiples of these branches, right? And what happens here is that you're working on software in different areas, and again, that's not always the case, not always in different areas, where you're basically creating different functions. So for example, if I were to use an example of an application for a phone, maybe this one is building some kind of a location or GPS based positioning. So this person is working on a GPS, this person is working on UI for the maps, and this last person is working for some kind of features for the users, right? And so all these people are working based on this build, and so they're working simultaneously or in parallel on this new version of software, right? And so as they complete the task, you now need to merge this back into the main revision. And again, I'm not going to go into all the functions of Git, but ultimately it is possible to merge code into one single application that is built by multiple individuals. And that is the main, I want to say, benefit of Git, that you can basically have multiple parties work on the same software in different areas, and it allows you to easily, first of all, to merge that in, but it also allows you to go back. So for example, if we're not liking this UI and maps, you can go back to this revision, you can branch off to another point, and you can create some kind of a different version. You can then branch back. And so ultimately you could see how this can benefit a lot of teams that are looking to build software in parallel. So now that we're on the same page when it comes to this, let's start talking about the manufacturing space. So in manufacturing, the challenges are a little bit different. And by the way, we didn't really talk about DevOps and what that truly means to deployed code in production. But ultimately, this is going to be very critical for manufacturing because software is built and is deployed very differently. So in manufacturing, you have what are called, again, PLCs. And PLCs are basically hardware. So you would have a programmer or number of programmers that will create software that, for example, goes into this PLC. Then you have another terminal. And again, I'm explaining this a little bit briefly, but you can have a terminal or you can have a server that contains the software, but ultimately your code is going to reside in your PLC as the runtime. And what I mean by runtime is this is actually what's executing on the PLC to run your inputs, to run your outputs, and to make production work. So typically, you would either have, let's say you have the software on this machine, you would build the software and then you would pass it on, or you would download the file to the PLC. And by the way, this is a side note where this gets a little bit confusing. When we say download in the world of industrial automation, we mean download to the PLC, so sending the software from the laptop to the actual machine, versus the other way around that we're traditionally used to. When I'm downloading a file is I'm pulling it to my machine. But anyways, the point here is that you would develop the software on this machine. You can then connect to different PLCs to deploy that software. So number one, it is very rare, or I would say it is uncommon, to see multiple people working on the same software package in industrial automation. The reason for that is because traditionally you have a natural split. So this is, for example, machine 1, this is, for example, machine 2, machine 3, so on and so forth. So it's always easy, if you have, for example, 3 engineering resources, to just split them up on different machines. So this person is going to develop whatever software for machine 1, this person for machine 2, this person for machine 3. So it is going to be a different challenge. It is not necessarily that they're building a very large piece of software, is that they're building smaller softwares for different machines. So that is the first challenge and big difference when it comes to building software in manufacturing or the industrial setting. The other challenge that is extremely important to discuss is the fact that there's a big difference between, as I've mentioned, developing in production and developing for the development life cycle. So in this case, in many instances, it is almost impossible to simulate the software that you've built on your PLC. And the reason for that is it's not because of the lack of tools, right? So there's very good tools in TIA Portal, in Studio 5000, in Codesys. You can run the simulations all day long. What you cannot do is have the physical machine that will actually work and run so that you could see what the result of your code is until you push it to the machine. So what I mean by that is, for example, if this is some kind of a tank that needs to fill up with a certain liquid and it needs to hit certain sensors, you can simulate on your laptop a tank that's going to fill and that's going to discharge, but until you see the real liquid and the actual physical positioning of the sensor, reading the height of that tank, or maybe the load cell interacting with the tank and having a real world signal that's coming back to your system, it's very difficult to say how it's going to work. So to that point, a lot of development when it comes to PLCs and even HMIs or SCADAs is really dependent on building that software and pushing it to the machine, versus in the software world, on the IT side, a lot of it is going to be tested within what's called CI/CD pipelines, and basically there's going to be unit tests. And again, I'm not saying it is not possible in the industrial setting. I am just saying that you can test the code, but it's very difficult to simulate the physical presence of the machine. So if that's the case, why should we even care about Git? What benefits does it provide in manufacturing? What are some of the challenges, maybe some of the opportunities? We've talked about a couple of challenges, but ultimately, let me illustrate a couple more. Like I said, the PLC is going to have the runtime of the application. What usually happens in the manufacturing setting is that you have that PLC tied to your HMI, right? So this is going to be HMI, HMI, and this is your PLC. The problem, or I guess the challenge here, is that your PLC will interact with the HMI via registers, right? And so your registers are going to be changed based on the inputs, not only from the system, but also based on the interactions from the operators. So a specific example would be, I don't know, you have a batch, right? So you have a tank where you have a certain temperature set point set for your batch. So for example, again, like this is a temperature sensor right here on the tank, and this is tied back to your PLC input card, and this is going to be T T1, for example, and this temperature for this specific batch needs to reach, I don't know, let's say 40 degrees C for, I don't know, 2 hours, right? So 2 hours, it's nearly room temperature, slightly above that. And then for a different batch, it needs to be set to 80 degrees Celsius, and it needs to be for 1 hour. So the problem here is that these variables or these registers are not necessarily part of what's called the PLC program, right? So the programmer has created a routine and a set of logic files that will be put on the PLC with the intent that the registers can be set to whatever they need to be set via the HMI by the operator for that specific batch. So when you're trying to version control a PLC program, you do not necessarily just want, so this is going to be the file, so PLC program. You do not necessarily just want the PLC program, you also want to be able not to track necessarily what the register was at every single point in time, but you want to have a certain record of some of those registers as they're being set by the HMIs, operators, or somebody else. Those registers can also be changed by the programmer. So for example, there's going to be hard set values in that program that can be changed and can be pushed to the PLC, right? So this is a program that can be downloaded to the PLC at any point in time. So you want to understand this program got pushed at 6 p.m. today. What has actually changed on that program, and how did that affect the registers that are ultimately going to affect our batch? So basically what I'm trying to say here is that your Git solution, whatever it may be, needs to not only ingest the files, right? So not only the program, but it also needs to have some of the context or some of the registers from the PLC into it. Unlike the IT side, where software a lot of times is not going to have any context for the user. So for example, if I go into an e-commerce platform and I create my username and password, I have a database where that is stored. In this case, this is basically stored on the PLC in the internal registers, so it becomes more difficult for me to capture what is happening here. Now, we've talked a lot about the challenges. What are the opportunities? Like I've mentioned, number one, if you start having a system where you have different problems on your plant due to changes, or maybe you have different vendors working on software and someone's making a change that you've perhaps not requested or not approved, you now have a way to see different versions of your software. You also have the opportunity of, if you have a system that contains these files, you could say, for example, so this person can view it, so this is viewer, and this other person has permissions to edit, right? So for example, a viewer might be like an operator. Similarly, it could be a technician depending on their level, right? So tech. But the editor could be controls engineer, could also be a contractor, so an OEM that requires access to view some of the versions or maybe push an update to their system. And you can also restrict access based on time. So when the machine is down, for example, for sanitation, you can make it available for the control systems engineers or the OEMs to make updates. And you can allow the viewers, of course, to see the program at any point in time. You now have the capability of developing software and pushing software independently by multiple groups. So if you have an engineer that's going to work on a very specific application that is applicable to multiple PLCs, that could be an AOI or a UDT in the realm of Allen Bradley or Rockwell Automation, but ultimately they can create a piece of code, right? So this is, for example, user 1, and this is going to be user 2. So they've created code independently. They can now push it to this version similar to how I explained it on Git independently. So basically they're working on the same larger software for that specific machine that can be part of a different plant, but it can also be part of other facilities that the same company has. And they're pushing those different updates to a single source of software. The last feature that's extremely important in manufacturing is the fact that, so for example, you have this in Asset Center and other tools, is you can only have one copy allocated at a time. So for example, if Vlad is looking to make some changes Vlad will basically check out the copy of this file, right? So this is going to go to Vlad, and nobody else is able to make those changes until Vlad pushes the file or the update back in, and then it can be validated before it's actually pushed to the PLC. So that is also a huge opportunity, because a lot of times when I go to different facilities, I would ask who's got the software. And someone on third shift inevitably has a laptop with all the files, all the PLC programs, all the HMI programs that has made a bunch of changes, or other people have made changes. They pulled it from the PLC, some of them pulled it from a drive that was old. So now there's no single source of truth for those files. So the opportunity is really big. A lot of different sites are deploying different solutions. I named a couple of them, but ultimately it really depends what state you are in. So if you're a very small manufacturer, for example, if you don't have anybody programming on the shop floor, I would argue that the OEMs or whomever is servicing your machines, it could be integrators, should be handling a lot of the version control and should be looking at some of these tools. If you have a team of a couple of engineers, if they're one, for example, is responsible for the palletizing area or the warehouse, the other one is responsible for the process area or the transformation area, chances are they can manage it on their laptops or maybe a central hard drive or repository. But as you start scaling a manufacturing company, you should be looking into these solutions, because if you have multiple people accessing the software, if they have an old version of the software, if they have, like I said, if someone on a third shift has software on their laptop that could be compromised, that becomes a real problem. So you can basically have, how do you deploy something like this? You can either deploy on Git natively. So Git is free of charge. It is a tool that allows you to version control your software, but Git is limited also. So there's a reason why Git has not been extremely popular in the industrial automation space. And the reason for that is, and I mentioned a couple of challenges, but one of them also is that you cannot view the software that you've developed. And so if you've not seen Git, basically when you go and you look at, so for example, this is V1 of your software, in your window, you would actually see the code, and you could see, if I'm reviewing that program, I could see, hey, there's an issue here on this line, we need to make those changes. And I can basically view all the code as if it was written by myself, and I could understand the code without having to edit that in an editor. For PLCs, that is not possible. So because we are a smaller or a more niche solution, the PLC viewer of ladder logic or function blocks or even structured text, it's not going to display because it is not in a language that Git understands. So if you go on a solution like GitHub, or if you look at GitLab, for example, and if you upload your PLC code, you'll be able to version control, but you'll not be able to see it, you'll not be able to edit. You will need the actual tools or the IDEs for those specific solutions to be able to use them. So long story short, like I said, there have been tools developed for this specific use case, and now you're able to version control, you're able to push code, you're able to see who's making changes, you're able to see where the code is going, and you're able to get more people involved in the development. And so that's the overview of Git and version control when it comes to manufacturing and industrial automation. If you have any questions, if you want to reach out about any specific projects that maybe you're working on or at least thinking about, don't hesitate to send me a note either here in the comments, or you can also reach me on LinkedIn or by email. All of that will be posted in the description, and I will see you next time.